What's going on, guys? Let's see how we can find the intervals of convergence for this power series. So first of all, what we have to do, we have to do the ratio test to find where the ratio is less than 1, right? So we have to find that one first, and let's go ahead and do the ratio test. Here, limit n approaches infinity, and ratio test is basically we take the absolute value an plus 1 over an. So this is what we do in ratio test, right? So an plus 1 is basically we add 1 to the n. Wherever we have n, we just add 1 to that. So here we are going to have n plus 1 cube times x minus 5 power n plus 1. And since we have no denominator, we can write the original function in the denominator. An is going to be this function, that's going to be n cube x minus 5 power n. And let's cancel everything we can cancel, and from this one you can notice this one cancels with this one, so we are left with x minus 5 power 1, right? Because if you see that this is same as x minus 5 power n times x minus 5 power 1. So that's why we can cancel this power n and we are left with x minus 5 power 1. And we have this one remaining, and let's see what we can do with this. So here we are going to have limit n approaches infinity. Since both of them have power 3, we can write them together. Like we have x minus 5, let's write that one front, x minus 5, and in the big bracket we have n plus 1 over n power 3, right? And now what we can do is, since we are taking the limit in terms of n, x minus 5 is going to be constant because everything except n is going to be constant, so we can move this one to the front. So let's go ahead and move that one to the front, and if you do, we are going to have absolute value of x minus 5 in the front, and then we have limit n approaches infinity n power plus 1 over n power 3. So both of them have same power, therefore the ratio is going to be the limit, and this is 1 over 1. So this is going to be the limit of this one. So finally we have found the total value, the ratio is going to be x minus 5, right, in the absolute value. So this is going to be the value, that is ratio that is less than 1. Now what we have to do, we have to find the interval of convergence. To find that, what we do, since this is absolute value, right, so this is between negative, we take this one between negative 1 and 1, x minus 5, negative 1 and 1. Then if I move this 5 to this side, this is going to be positive, right? It's like, treat this one like an equal sign, and this is positive 5. So positive 5 minus 1 is going to be 4, right? 4x, and if you move this negative 5 to this side, this is going to be again positive 5. Positive 5 plus 1, that's going to be 6. So the new interval is 4 to 6. X is between 4 and 6. Now what we have to do, we have to take this endpoints and check whether it is converging at endpoints. If it's converging, we put in this bracket. If it's diverging, we put it in round bracket, right? So let's see what we get from this one. So first of all, let's plug the 4 in the original equation. We are going to plug this one in original equation and check whether it converges in that situation. So let's bring the original equation right here. N is equal to 0 to infinity n cube and x. First of all, let's take the 4. We are taking n is equal to, x is equal to 4 and checking. So if you apply 4 right here, this is going to be 4 minus 5, that's going to be negative 1, right? So this is going to be negative 1 power n. And if you notice, this is an alternating series. When you have negative 1 power n, that is an alternating series. To prove an alternating series converges, we have to take the limit and see whether it is equal to 0, and we have to show that it's decreasing. If it fails one of them, it means it diverges. So let's go ahead and take the limit first. So limit n goes to infinity, and we only take bn value in the alternating series. So this is going to be the bn value. Everything except -1 is going to be the bn value. So this is what we are going to take the limit for. And let's take the limit and see what we get. Limit n approaches n cube, limit n cube, and if you apply infinity for this one, this is not equal to 0. So this fails the first test. If it fails one of them, this means this diverges. So this one diverges. So this is definitely going to be in the round bracket. So let's go ahead and put 4 in the round bracket, and let's see what happened to the next one. So we have 4 and 6. So this one fails the convergence test. Now let's go ahead and find the convergence test for this one. And if you apply 6 for this x value, this is going to be 6 minus 5, that's going to be positive 1. So let's write this one right here. So here we are going to have sigma n is equal to 0 to infinity, and n cube times 1. So x 6 minus 5, that's 1 power n, right? This is what we are going to have. And 1 power anything is going to be 1. Now here what we can do is we can take the check with the limits for divergence. I mean test for divergence. So if you take this test for divergence is basically you take the limit for whatever the value we have, limit n approaches infinity and n cube. If it's not equal to 0, that is a divergence. So this is definitely not equal to 0. If you apply infinity for this one, infinity power cube, definitely not equal to 0. So from limits for divergence, this is failing the convergence test. If it's 0, it may converges or diverges. But if it's not equal to 0, it definitely diverges. So this also diverges. Therefore, both of them are going to be in the round bracket. So this is going to be the interval of convergence is going to be 4, 6 in the round bracket. So 4, 6 in the round bracket, and that's going to be the final answer for this question. I hope you guys find this video helpful. See you next time.